Assalamualaikum warahmatullahi wabarakatuh. Welcome to my channel. Hello guys, I'm Muhammad Surya Putra and you could just can call me Surya. And my student identification number is 0821113333040. And I'm currently majoring in physics undergraduate in University of Erlangen. So in this video, this video is presented for my midterm assignment of my physics, computational physics first course that I take this semester. So in this video, I will make a tutorial for problems in physics with coding using Octave. Specifically, I will analyze linear regressions with numeric method. And before we start, I want to tell you first because I will certainly use two different language here. The first is English and the second is Indonesian. So hope you guys enjoy it and let's just jump right into it. So, okay, first of all, we know that data collected from experiment physics phenomena can make a graphic. Let's show the relations between two or more variable which sensitive with each other's changes. So if we have these functions from the laboratorium professional, from scientific professional laboratorium experiment, and we get the function, we get the graphic. And when we are experimenting the same phenomena or the same experiment, we will have our own data that we collected from the experiment that we conducted. So this is how we compare these two data, which is from the laboratorium professional scientific data, we call it the literature results. So if our data is nearest as the same as the uh, literature result, which mean our data is likely to be more accurate. So uh, so, so as I said before, we already have the graphic from the literature result, which composed by the gradient or slope of the graphic that made from the literature result, and we have the constanta or the initial value of function, uh, and the value of it is constant, and we call it c. And then from it we compare our data to this component of this graphic data from literature result. So I will have the example. I will start screen first. Sorry first. So I have this example of data like this one. So I'll make this, yeah, like this one. So the green line on the graphic of the green line is the uh, data from the literature or the graphic from the literature, and our data is this like orange dot that we get from our own experiment in our own lab. Why this is happening is because we have this error from our experiment because we're not like professional of them, or the difference is from the environment of the lab itself, and this uh, pro the accuracy is not just from this human error or something, but is also contributed by this atmosphere, environment, and the quality of our um, measuring uh, instrument. So, and we see that our data, on this data, the orange dot is not linear. It's not like the same as this green data. That's why we need to know like the error. The error itself is contained R, which is regression, which is if the R is nearest to one, That means our data is close to the actual data or the data from literature. So the nearest to one, the more accurate our data will get. So first of all, the error is this in this particular is ESA and J, of course, which Y, this was Y guys is of course the line, this line. And if we square it, we will get this square from our each individual data. These equations is we will be using these equations in the next. So the first is, and then we get this equation, which is the gradient of our own data, comparing to the data from the collecting literature, and the C is the error. And of course, we would get the R. Okay, this is for why we this is the equations that we get it from. This is what we will use in Octave. So, and then we will got this one as well. Wait, this one, and then this one. So to this is I will explain on coding itself and stuff. So I'll this is our Octave worksheet. First of all, we need to wait to clean the memory for our new sheet. So let's just type CLC and clear all. And then let's just call it the title processing data processing, data processing. With first is let's identify the n. Variable n is the amount of data that we have. Let's say just we have 10 data. Let's just say we have 10 data. And we will make a data input with noise. This noise is to uh, uh, to find the M and C of our data and compare it to the data from the literature. So we have the SM. So beforehand, of course, from the literature, we have the M, the gradient of the slope M, which let's say we have the 0.4. And then for C, we have 5. Let's say 6. Let's just say 6 minus 6. And then we will type, we will call noise. Yes, noise. With 2, we'll make a half that produced by the value of the x will make, not the x, but the n. One, and the random itself will be generating a random, uh, a random value to one, from one to n. So we have this. So we will make a for function here. So for we let's just make this variable is equal to one for n, one n, which y e equals to this, let's say this e is the x. So from the equation we have the gradient, point e plus c, the constanta, and n, or with y equals to y plus noise. So let's just run this first of all. Let's see if it's working or not. Okay. Okay. Question two is question three. Okay, I just make it a question three. So I'm sorry, my video just froze. So we have this. So we have an error to it. Error near line 10. Near line 10. Oh yeah, this is not. Oh yeah, forget about this one. I'm sorry. Okay, let's just run it. Then we get this value, random value from the noise and from the RAM. So, and then we will processing the value of n. I just make a title processing the m value. So let's just say that from this one is, let's say, just for practical reason, we call it A, and this is the YE is B, and XI is C, and the sigma XI square is E, and the X and sigma square E square is C. So let's just type in it's equals to zero, the A's equal to zero, B, okay. B as well equal to zero as well. And so as the C, and no, yeah, there four of them equals to zero. And let's just make a function 4 with E equals mhm, with to N, and then the A equals to A plus 1, no, let's say the Y is the functions and the E is variable, is a changing variable. Of course. Mm, when b equals to b, oh wait, let me, okay, it's y. Actually, I need to uh, check it out before I run it, of course, because I tend to make a mistake. That's why, that's why people. And then, no, just put here plus the E1, no, and then with D plus E square. E square. Let's just N. And 4. And then we get this and A minus B times C or N, N1. And so is the amount of data that we have. So yeah, let's just run it first. So we need to know. Yeah, we got the M. The M is 0.7, which is very different from our initial M. This is our initial M. It is because uh, our data, we have to put our data first. So, and this data, what we get this is from noise, and then we process the M value and we get this one. So this is the value from our data, the value, slope value of our data. And then, of course, we will have to find the C. Let's just processing, processing C value, value, value of C. So the Y is 0. Say the Y is 0, the X equals to 0, and then for E, let's just take E equals to 1. 1 to n, and y plus the function y. Wait, I got it. It's not like this. I'm sorry, guys. I'm pretty clumsy for this, right? I'm pretty clumsy for this, but yes. Okay, and we got the x equals to x plus a itself. Then we got for, and then c, and then c will value as y for n minus the gradient that we have before times x per n. So let's just run it first. Well, we have the c is minus 6.1, which is, of course, different from our initial data that we just, but this is close, right? So it might be our data is close, is accurate. So then Let's find our R of the regression. Calculate, calculate the R value with, like we know first, of course, like this one. The value of R is, I remember this one. We need this one. So we need this, this, and this. So let's just type it out. So let's just make it to n for the variable is equals to 0. And then e to h is equal to 0 again. So equals to 0. And then we have the function, the function a equals to first, 1 data, 2 n data. And the y equals y plus the function of y in e, and with y is, so y equals to y per n. And we have the 4 again. Oh my god. For e, of course, from 1 to n, a to m is equals to a to m plus this function of y. Minus the gradient that we have before with e plus 2 plus 2 plus 2, plus 4 plus 2, course, and then we square it up because as this equation right there, we square that out. So let's just, of course, and then the function for a to h, which a to h plus the function y is e minus y, and then we square it up again, and then we can for it. And then the value of 4 is, of course, is e to m minus a to, no, it's to h minus a to m or a to h. Just say it, and then we, no, why we just sqrt. Right, let's just find it. Wait, did I do wrong? But I think, oh, right. I think I read wrong. Yeah, definitely wrong. I'm sorry, guys. That's just so very clumsy. Yeah, we got the R is 0.1. This is very bad. This is very far from the value of 1. So we conclude that our data in this experiment is not very accurate or it's just far from literature results. So the last one is we have to plotting or we visualize, make a plot. The graphic, visualizing the graphic. So first of all, we plot, we use plot the equation y with x. This is the axis. We need this axis. Oh, on to plot plot um in plus c. Or what? What? Just running out. Okay. Sorry guys, my video just froze. So this is the final result. We have this plot. So let's say this line, the research line, and this is the line, and this is our result of data. But we actually don't have the data. We just found data from the generating the random value on the coding. So of course you have to generate your own data, not generate, just input your own data and compare it to the literature one using this method of numeric method in analyzing linear, at least linear regression. So I think this is conclude our tutorial this time to of analyzing at least regression linear with numerical method in using Octave. So this is I will conclude this all and this is the end, guys. Thank you for watching my videos and hope you get help from this video. So I am sorry for the trouble that I made because my video just literally froze every time because my Wi-Fi is not really well. So uh, I think that's it. Hope you enjoy and get this idea of. So I will stop sharing first. Stop sharing. Okay, guys, I'm sorry. I'm so okay. Okay. Because this tutorial ended, so I will end this video. Uh, so thank you once again, guys. Thank you so much for watching, for supporting. And if you from this is require, okay, this is require a comment from university, big university in Indonesia. There is UE, ITB, and UGM, just for engineering, who the people who engineer the uh no people who majoring in engineering. So if you are from those three university and majoring engineer, please comment my video in this below so I can get uh what I say opinion you get from. And if you want to ask, if you want to ask, or if you confuse my tutorial in this video, you can just click comment and type below so I can answer you. Or you, if I am doing wrong in this tutorial, you can correct me so I can get better on my coding in physics. So hope you enjoy and hope you get help from my videos. See you next time. Bye.